ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ವೆಲ್ಕಮ್ ಟು ಮೈ ಚಾನಲ್. ನನ್ನ ಚಾನಲ್ಗೆ ಸ್ವಾಗತ. ಈ ವಿಡಿಯೋಲಿ ಸ್ನೇಹಿತರೆ, ನಾನು ಇತ್ತೀಚೆಗೆ ನಡೆದ TET ಪರೀಕ್ಷೆಯಲ್ಲಿ ಪೇಪರ್ 1 ಮತ್ತು ಪೇಪರ್ 2 ಎಕ್ಸಾಮಿಗೆ ಕ್ವಾಲಿಫೈ ಆಗಿ Gpstr ಎಕ್ಸಾಮ್ಗಳಿಗೆ ಈಗ ತುಂಬ ಜನ ಪ್ರಿಪೇರ್ ಆಗ್ತಾ ಇದ್ದೀರಾ. ಆ ಎಲ್ಲರಿಗೂ ಮೊದಲನೇದಾಗಿ ನಾನು ಈ TET ಪೇಪರ್ 1 ಮತ್ತು ಪೇಪರ್ 2 ಪರೀಕ್ಷೆಗಳಲ್ಲಿ ಕ್ವಾಲಿಫೈ ಆದವರಿಗೆ ನನ್ನ ಚಾನಲ್ ಮುಖಾಂತರ ಎಲ್ರಿಗೂ ಒಂದು ಶುಭಾಶಯಗಳು ಹಾಗೂ ಅಭಿನಂದನೆಗಳನ್ನು ತಿಳಿಸಿ, ಈಗ Gpstr ಎಕ್ಸಾಮ್ಗಳಿಗೆ ತಾವೆಲ್ಲ ಪ್ರಿಪೇರ್ ಆಗ್ತಾ ಇದ್ದೀರಿ. ತಾವೆಲ್ಲ ತುಂಬ ಬುಕ್ಸ್ಗಳು, ತುಂಬ ಪೇಪರ್ಸ್ಗಳನ್ನು, ತುಂಬ ಕ್ವಶನ್ಸ್ ಪೇಪರ್ಸ್ಗಳನ್ನು ನೀವು ಅನೇಕ ರೀತಿಯಲ್ಲಿ ನಿಮ್ಮ ಪ್ರಿಪ್ರೇಷನ್ಸ್ಗಳನ್ನು ಮಾಡ್ತಾ ಇದ್ದೀರಿ. ಅದೇ ರೀತಿ ನಮ್ಮ ರಾಜ್ಯ ಸರ್ಕಾರವು ಇತ್ತೀಚೆಗೆ ಅಂದರೆ ಇನ್ನು ಮೇ ಬಿ ಒಂದು 15-20 ಮ್ಯಾಕ್ಸಿಮಮ್ ಒಂದು ತಿಂಗಳಲ್ಲಿ Gpstr ಎಕ್ಸಾಮ್ ಕಾಲ್ ಮಾಡ್ಬೋದು ಅಂತ ಎಲ್ರಿಗೂ ಆಸೆ ಇದೆ. ಎಲ್ರಿಗೂ ಒಳ್ಳೆಯದಾಗಲಿ, ಶುಭವಾಗಲಿ. ನಾನು ಈ ಚಾನಲ್ ಮುಖಾಂತರ ತಮ್ಮೆಲ್ಲರಿಗೂ ಯಾರ್ಯಾರು Gpstr ಎಕ್ಸಾಮ್ಗಳಿಗೆ ಪ್ರಿಪೇರ್ ಆಗ್ತಾ ಇದ್ದೀರಾ ಅವರಿಗೆ ಸ್ವಲ್ಪ ಈಸಿ ಆಗಲಿ ಅಂತ, ಸ್ವಲ್ಪ ಹೆಲ್ಪ್ ಆಗಲಿ ಅಂತ ನಾನು ಒಂದು ವಿಡಿಯೋ ಸೀರೀಸ್ಗಳನ್ನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಆ ವಿಡಿಯೋ ಸೀರೀಸ್ಗಳಂದರೆ, ಈ ಸೈನ್ಸನ್ನು ತುಂಬ ಜನ ಈಗ ನಮ್ಮ ರಿಲೇಟಿವ್ಸ್ ಆಗಲಿ ಅಥವಾ ನಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗಳಾಗಲಿ ನನಗೆ ಕೇಳ್ತಾ ಇದ್ರು, ಸೈನ್ಸನ್ನು ನೀವು ಇಂಗ್ಲೀಷಲ್ಲಿ ಸ್ವಲ್ಪ ವಿಡಿಯೋಸ್ಗಳನ್ನು ಮಾಡಿ. ಯಾಕಂದರೆ Gpstr ಸೈನ್ಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ, ಇಂಗ್ಲೀಷ್ ಮೀಡಿಯಂ ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ ವಿಡಿಯೋಸ್ಗಳು ಕಡಿಮೆ ಇದ್ದಾವೆ, ವಿಡಿಯೋಸ್ಗಳನ್ನು ಮಾಡಿ ಅಂತ ನನಗೆ ತುಂಬ ರಿಕ್ವೆಸ್ಟ್ ಮಾಡ್ತಾಯಿದ್ರು. ಕಾರಣ, ನಾನು ಈ ಸೈನ್ಸ್ಗೆ ಸಂಬಂಧಪಟ್ಟಿರೋ ವಿಡಿಯೋಸ್ಗಳನ್ನು ಇಂಗ್ಲೀಷಲ್ಲಿ ತಮಗೆ ರೀಚ್ ಮಾಡಲಿಕ್ಕೆ ಪ್ರಯತ್ನ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಹಾಗಾಗಿ ಯಾರ್ಯಾರು TET ಎಕ್ಸಾಮ್ ಕ್ಲಿಯರಾಗಿ Gpstrಗೆ ಪ್ರಿಪೇರ್ ಆಗ್ತಿದ್ದೀರಾ ಎಲ್ರಿಗೂ ನಾನು ಏನು ಕೇಳ್ಕೊಳ್ಳೋದು, ನನ್ನ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ ಬೆಲ್ ಐಕನ್ ಮೇಲೆ ಕ್ಲಿಕ್ ಮಾಡಿ. ಯಾಕಂದರೆ ಈ Gpstrಗೆ ಸಂಬಂಧಪಟ್ಟ ಅನೇಕ ಕ್ವಶನ್ ಪೇಪರ್ ವಿಡಿಯೋಸ್ಗಳಾಗಲಿ ಅಥವಾ ಈ ಸಬ್ಜೆಕ್ಟ್ ರಿಲೇಟೆಡ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಆಗಲಿ ನಾನು ವಿಡಿಯೋಸ್ಗಳನ್ನು ಮಾಡ್ತಾ ಇರ್ತೀನಿ. ಆ ಎಲ್ಲ ವಿಡಿಯೋಸ್ಗಳನ್ನು ತಾವು ನೋಡಬೇಕಾದಲ್ಲಿ ಬೆಲ್ ಐಕನ್ ಮೇಲೆ ಕ್ಲಿಕ್ ಮಾಡಿ ಅಂತ ಹೇಳ್ತಾ, ಈಗ ನಾನು ಮೊದಲನೇ ವಿಡಿಯೋವನ್ನು ನೋಡೋಣ, ಮೊದಲನೇ ಟಾಪಿಕನ್ನು ನೋಡೋಣ. ಏನಿದೆ ಆ ಮೊದಲನೇ ಟಾಪಿಕ್ನಲ್ಲಿ? ಲೆಟ್ಸ್ ಸಿ. ಫಸ್ಟ್ ಮೊದಲನೇದಾಗಿ ನಾವು ನೋಡೋಣ Gpstr 2021. ಇದು ಆ್ಯಕ್ಚುಲಿ Gpstr 2019 ಸಿಲೆಬಸ್ಸು, ಬಟ್ ಸೇಮ್ ಸಿಲೆಬಸ್, ಪ್ರಾಬಬ್ಲಿ ಸೇಮ್ ಸಿಲೆಬಸ್ ಇರುತ್ತೆ. ಇದು ಫಿಸಿಕ್ಸ್ ಸಿಲೆಬಸ್ಸು. ಫಿಸಿಕ್ಸಲ್ಲಿ ಮೊದಲನೇ ಯೂನಿಟ್ ಏನಿದೆ ಅಂದರೆ ಮೆಜರ್ಮೆಂಟ್, ಯೂನಿಟ್ಸ್ ಆ್ಯಂಡ್ ಡೈಮೆನ್ಷನ್ಸ್. ಲೆಟ್ ಅಸ್ ಸಿ, ದಿಸ್ ಈಸ್ ದ ಫಸ್ಟ್ ಯೂನಿಟ್ ಇನ್ ಫಿಸಿಕ್ಸ್. ನಾನೇನು ಮಾಡ್ತಾ ಇರ್ತೀನಿ ಅಂದರೆ, ಯೂನಿಟ್ ಬೈ ಯೂನಿಟ್ ಅಥವಾ ಒಂದೊಂದು ಯೂನಿಟಲ್ಲಿ ಒಂದೊಂದು ಟಾಪಿಕ್ಕು ಅಥವಾ ಎರಡೇ ಟಾಪಿಕ್ಗಳನ್ನ ಪ್ರತಿದಿನ ಒಂದು ವಿಡಿಯೋನ ಅಪ್ಲೋಡ್ ಮಾಡ್ತಾ ಇರ್ತೀನಿ. ಆದ ಕಾರಣ ದಯವಿಟ್ಟು ನನ್ನ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ, ಹಾಗೇನೆ ಬೆಲ್ ಐಕಾನ್ ಮೇಲೆ ಕ್ಲಿಕ್ ಮಾಡಿ. ಸೊ ಯು ಕ್ಯಾನ್ ವಾಚ್ my videos every day on a single topic or maybe 1 or 2 topics. So what I will be doing hereafter is I will be taking 1 or 2 topics from your syllabus, that is Gpstr syllabus, and then I will try to explain whatever is possible from my side. So hence I request you to subscribe to my channel and also click on the bell icon for more updates on my channel. So let us see what is the syllabus over here for Gpstr physics. The first unit is measurement, units and dimensions. See, this is the syllabus for first unit, that is fundamental and derived units, fundamental forces in nature, measurement of longer distance object like sun, planets, extra measurement of very small distance like size of atoms, error types of and significant errors. Okay, so let us try to see this topic or these topics in detail. Let me start with first topic, that is measurement. Let us try to understand what is measurement and then try to look deep into this subject. Let me minimize a bit and then okay. See, let us try to I am trying to just zoom it, otherwise it's okay, not an issue. See here, let us see the history of measurement. Before humans created a standardized unit of measurement, Many cultures utilized local traditions for measuring objects. See, before the standard methods or standard measuring units are found, ಆ ಮೆಜರಿಂಗ್ ಯೂನಿಟ್ಸ್ಗಳನ್ನು ಕಂಡುಹಿಡಿಯೋಕ್ಕಿಂತ ಮುಂಚೆ ಏನಾಗಿತ್ತು, ಬಿಫೋರ್ ದೇ ವೇರ್ ಫೌಂಡ್, ಮೆನಿ cultures utilized different cultures utilized traditions, traditional methods of measuring the objects or measuring the units or measuring the objects. These are follows. That means before the standard units were found, they were following the tradition units for measuring. Let us try to see first. The tradition which they followed is cubit. This measurement originated in Egypt about 3000 BC. That means this is the traditional method that was used before the standard methods were found. Similarly, we have fathom. It is a unit of length in the imperial and US customary systems equal to 6 feet. See, this was a fathom was a unit that was used before the standard methods where measurement units were found. Similarly, a handspan. Handspan, it is the distance between a tip of small finger and at the tip of thumb. That means we call a span. Handspan is the tip of small finger and a thumb. So this is usually we even do it today to measure some smaller distances. If you don't have scale at our place, then we use the handspan to measure. Handspan in the sense like we take the tip of a small finger and tip of a large finger, that is thumb, and then start measuring it. So these were the traditional methods they were using before the standard methods were being found. So let us see. And what we have next is in this measurement, let's go net. Okay. One sec, maybe. Okay. Okay. What we'll see, let us try to understand what is a need for measuring this or any objects. Let us try to understand why do we have to measure the objects. What is a need for measurement? Say as a physician, or I mean as a physicist, what I can do as a physics enthusiast to understand the natural phenomena. See, why do we have to measure something? Because we have to understand why it is so long, why it is so short. So we have to understand the natural phenomena. In order to understand the natural phenomena, we have, we are interested in measuring something. So I will search for some answers, like for why did the ball fall from the ground, at what speed does the object fall. See, if there was a ball falling from sky to the ground, then obviously, as a physics person, I'll try to think why the ball is falling, or why did the ball fall on the ground? At what speed does an object fall? Is the velocity of ball constant? How much time will it take for a ball to reach the ground? Or is the velocity of any body directly related to its mass? So these are some common questions that arise in every person when he sees, like, if he is interested in understanding, or if he interested in knowing what is the concept behind or what is the physics behind it, then obviously he'll have to ponder over these questions. Then, so this is what the need of measurement that we have to understand. Like, we'll always or often ask the questions like why do you have to measure things. It is only because we have to understand the science behind it in order to understand the logical or scientific principles relating to that action that is being taken. So that is why we have to know, or we have to measure the things. Let us try to understand a system of units. What is a system of units? We have heard units, but what is a system of units? See, let me try to read it out here. Let me zoom it a bit. The system of unit is the complete set of units. System of units is the complete set of units, both fundamental units and derived units for all kind of physical quantities. That means it is a unit, it is a system. It is a different part. It is a separate part which has both fundamental units as well as derived units. Let us try to understand what is fundamental unit and what is derived unit in later part. Let me directly go into the example here. FPS or foot pound system. This is British engineering system of units that uses foot as a unit of measurement of length and pound as the unit of mass and second as the unit of time. See here, these are different systems, or these are different methodologies they adopt in measuring some things. For example, British engineering system uses foot as unit of measurement of length. To measure the length or to measure length of something or any object, it uses this system uses foot as unit and pound as the unit of mass. To measure any mass, it uses pound, and second as the unit of time. To measure any time, the unit is second. That means foot pound system, FES system we call it as, right? So similarly, we have one more system here, CGS, that is centimeter, gram, and second. So to measure any length, any distance, it uses centimeter. To measure any mass, to measure any weight, it uses gram, and to measure any time, it uses second. A Gaussian system, we call it as CGS, is Gaussian system that uses centimeter, gram, and second as the three basic units for length, mass, and time. Length is for centimeter, gram is for mass, second is for time. So this is CGS system. This system, see, what we have to understand is system as a whole, system as a complete system which has all units included in it. Similarly, MKS, meter, kilogram, and second. Similarly, again, to measure the length in MKS system, we use meters, and to measure the mass, we use kilogram, and to measure distance, again, we use second. See, the fundamental unit of length, mass, and time are meter, kilogram, and second respectively. These are the three major system of units, that is FES, CGS, and MKS. Hope you are understanding. Next, we'll try to see what is fundamental and derived units. Let us now understand fundamental and derived units. See, fundamental, there are few units which are which we call them as fundamental units, and few units which we call them as derived units. Let us try to understand fundamental units. Fundamental units are the quantities which we can measure directly. The quantities which we can measure directly. For example, if I have a book, then I'll say the weight of book is 5 kilogram, or weight of book is 2 kilogram. That means this 2 kg is not depending, or we are not depending on any other quantity. So we'll again try to understand fundamental ಅಂದ್ರೆ ನಾವು ಯಾವುದೇ ಕ್ವಾಂಟಿಟಿಯನ್ನ ಅಥವಾ ಆ ಆಬ್ಜೆಕ್ಟ್ದು ಆ ಪ್ರಾಪರ್ಟಿಯನ್ನ ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಕಂಡುಹಿಡಿಬಹುದು. ಆ ಪ್ರಾಪರ್ಟಿ ಕಂಡುಹಿಡಬೇಕಾದ್ರೆ ನಾವು ಇನ್ಯಾವುದೋ ಆಬ್ಜೆಕ್ಟ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಲ್ಲ. ದಟ್ ಮೀನ್ಸ್ ದಿಸ್ ಕ್ವಾಂಟಿಟಿ ಡಸ್ ನಾಟ್ ಡಿಪೆಂಡ್ ಆನ್ ಎನಿ ಅದರ್ ಕ್ವಾಂಟಿಟಿ of any other object or this object at all. For example, basic quantity, mass. Every object has mass, right? To measure the mass, we do not require the speed, we do not require or its length, weight, I mean its length or its height. To measure the mass, we can directly measure it. We don't depend on any other quantity to measure the mass. And let me go to next page here, we'll understand it. See, first one is fundamental quantity. Fundamental The physical quantities that do not depend upon other quantities are fundamental quantities. See, fundamental quantities are the physical quantities. These quantities do not depend. ಆ ಕ್ವಾಂಟಿಟಿಗಳು, ಕ್ವಾಂಟಿಟಿ ಅಂದರೆ ಗೊತ್ತಾಗುತ್ತಲ್ಲ ನಿಮಗೆ. ವಾಟ್ ಡು ವಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಬೈ ಕ್ವಾಂಟಿಟಿ? ಕ್ವಾಂಟಿಟಿ ಈಸ್ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ಎನಿ ಆಬ್ಜೆಕ್ಟ್. Property of any object. Let us take for example, I have a ball. Ball is half a kg. So that mass is a quantity, that weight is a quantity. A weight and a measure madake, to measure that weight we do not depend on height of the ball or width of the ball or quality of the ball. We don't require any other quantity to measure this weight. The weight or mass is a separate quantity. This quantity doesn't depend on any other quantity of an object. Hope you are understanding this. So for example, base quantity, see length. To measure length of any object, we don't require to measure height or we don't require to measure its weight. ಈಗ ಒಂದು ಲೆಂತ್ ಅನ್ನ ಮೆಜರ್ ಮಾಡಬೇಕಾದ್ರೆ, ಯಾವುದೇ ವಸ್ತುವಿನ ಒಂದು ಲೆಂತ್ ಅನ್ನ ಮೆಜರ್ ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಅದರದ್ದು ಹೈಟ್ ಎಷ್ಟಿದೆ, ಅದರದ್ದು ವೇಟ್ ಎಷ್ಟಿದೆ, ಅದರದ್ದು ಕಲರ್ ಯಾವುದಿದೆ, ಇದನ್ನ ಯಾವ್ದ್ರ ಮೇಲೂ ಡಿಪೆಂಡ್ ಆಗಲ್ಲ. ಅದು ಎಷ್ಟು ಸ್ಪೀಡಲ್ಲಿ ಓಡ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನು ನಾವು ಡಿಪೆಂಡ್ ಮಾಡಂಗಿಲ್ಲ. ಸೊ ಡೈರೆಕ್ಟ್ ಆಗಿ ನಾವು ಅದನ್ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಮೆಜರ್ ಮಾಡ್ಬೋದು, ಲೆಂತ್ ಎಷ್ಟಿದೆ. ಸೊ ಇಲ್ಲಿ ನಾವು ಏನು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು, ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಹಿಯರ್ ಇಸ್ ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟೀಸ್. ಯಾವುದೇ ಆಬ್ಜೆಕ್ಟ್ ತಗೊಂಡಾಗ, ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ತೀನಿ, ಯಾವುದೇ ಆಬ್ಜೆಕ್ಟ್ ತಗೊಂಡಾಗ ಅದರದ್ದು ಒಂದು ಗುಣ, ಅದರದೊಂದು ಪ್ರಾಪರ್ಟಿ, ಅದರದೊಂದು ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಅನ್ನ ನಾವು ಮೆಜರ್ ಮಾಡಬೇಕಾದ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ನಾನು ಮೆಜರ್ ಮಾಡೋ ಕ್ವಾಂಟಿಟಿಗಳಿಗೆ ನಾನು ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟಿ ಅಂತ ಕರಿತೀನಿ. ಆ ಕ್ವಾಂಟಿಟಿಗಳನ್ನ ಮೆಜರ್ ಮಾಡಬೇಕಾದ್ರೆ, ಆ ಕ್ವಾಂಟಿಟಿಗಳನ್ನ ನಾನು ಕಂಡುಹಿಡಿಬೇಕಾದ್ರೆ ಇನ್ಯಾವುದೋ ಕ್ವಾಂಟಿಟಿ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಲ್ಲ. ಈಗ ಉದಾಹರಣೆಗೆ ಲೆಂತ್ ಅನ್ನ ನಾನು ಕಂಡುಹಿಡಿಬೇಕಾದ್ರೆ ಇನ್ಯಾವುದೋ ಕ್ವಾಂಟಿಟಿ ಮೇಲೆ ನಾನು ಡಿಪೆಂಡ್ ಆಗಂಗಿಲ್ಲ. ಸಿಮಿಲರ್ಲಿ ದ ಯೂನಿಟ್ ಆಫ್ ಲೆಂತ್ ಇಸ್ ಮೀಟರ್. ಮಾಸ್ ಅಂದ್ರೆ ಅದರ ತೂಕ, ಅದರ ವೇಟ್. ಮಾಸ್ ಅಂದ್ರೆ ವೇಟ್, ತೂಕ. ಮಾಸ್ ಅನ್ನ ಕಂಡುಹಿಡಿಬೇಕಾದ್ರೆ ಈಗ ನನ್ನ ಹತ್ರ ಒಂದು, ನಾವೆಲ್ಲ ಕೇಳಿರ್ತೀವಿ, ವಿ ವುಡ್ ಹ್ಯಾವ್ ಹರ್ಡ್ ಶಾರ್ಟ್ ಪುಟ್ ಬಾಲ್ ಟು measure its mass, that means to measure its weight. We don't require to understand, we don't require to know what is the height of that short put, or what is the width of the short put, or what is the quality of steel used. We don't require all such quantities or any other quantities to measure the mass. We can directly measure its mass. So that is how we call it as, again, fundamental quantity of an object is mass, we call kg. Time also is a fundamental quantity. Current also doesn't depend on any other quantity. Temperature of a body, for example, if I consider, again same thing, if I consider a shot put, if it is hot, I can directly measure how hot it is, how cool it is, ಎಷ್ಟು ಹಾಟ್ ಆಗಿದೆ, ಎಷ್ಟು ತಂಪಾಗಿದೆ ಅನ್ನೋದನ್ನ ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ನಾವು ಮೆಜರ್ ಮಾಡ್ಬೋದು. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಐ ಹ್ಯಾವ್ ಟು ಮೆಜರ್ ದ ಟೆಂಪರೇಚರ್ ಆಫ್ ಅನ್ ಆಬ್ಜೆಕ್ಟ್, or if I have considering that example, shot put example, if I have to measure the temperature of shot put, I don't require to know what is the height, again, what is the mass of the shot put, what is the weight, what is the height, what is the color. I don't require any other quantity to measure the temperature. I can directly measure the temperature. Such quantity are fundamental quantities. Luminous intensity, amount of substance, then plane angle and solid angle. See, plane angle and solid angles are, again, these are fundamental quantities. Plane angle is measured in radian, solid angle is measured in steradian. See, what is a plane angle? Plane angle is a angle at the center, subtended at the center by an arc. Okay, let us not go so much deep into this plane angle, steradian angle. So these are all just the examples of base quantities or fundamental quantities. Let us see derived quantities. Let us try to understand few of the derived quantities. See, the physical quantities, again, derived quantities also physical quantities. Physical quantities ಅಂದ್ರೆ physical ಗುಣಗಳು, ಒಂದು ವಸ್ತುವಿನ ಗುಣಗಳಲ್ಲಿ ಏನೇನು ಬರ್ತವೆ, ಅಲ್ಲಿ ವೇಟ್ ಬರುತ್ತೆ, ಅಲ್ಲಿ ಹೈಟ್ ಬರುತ್ತೆ, ಮಾಸ್ ಬರುತ್ತೆ, ಅದರ ಕಲರ್ ಬರುತ್ತೆ. ಇವೆಲ್ಲ ಫಿಸಿಕಲ್ ಗುಣಗಳು, ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್. ವಿ ಕಾಲ್ ದೀಸ್ ಆರ್ weight, height, mass, width, all those quantities related to that particular object. Physical quantities that depend upon the fundamental quantities are known as derived quantities. Those quantities, there are some quantities related to a ಆಬ್ಜೆಕ್ಟ್. ಒಂದು ವಸ್ತುವಿಗೆ ಕೆಲವೊಂದು ಕ್ವಾಂಟಿಟೀಸ್ಗಳು ಹೆಂಗೆ ಕಂಡು ಹಿಡಿತೀವಿ ಅಂದರೆ, ಯಾವ ರೀತಿ ಕಂಡು ಹಿಡಿಬೇಕಾಗುತ್ತೆ ಅಂದರೆ, ಅವುಗಳ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ಗಳನ್ನು ಒನ್ ಆರ್ ಮೋರ್, ಒಂದು ಅಥವಾ ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ಗಳನ್ನು ತಗೊಂಡು ಅದರದ್ದು ಇನ್ನೊಂದು ಕ್ವಾಂಟಿಟಿನ ಕಂಡು ಹಿಡಿಬೇಕಾಗುತ್ತೆ. ಆ ರೀತಿ ಇರೋ ಕ್ವಾಂಟಿಟೀಸ್ಗಳನ್ನು ನಾವು ಡಿರೈವ್ಡ್ ಕ್ವಾಂಟಿಟೀಸ್ ಅಂತ ಕರಿತೀವಿ. ಡಿರೈವ್ಡ್ ಕ್ವಾಂಟಿಟೀಸ್ ಆರ್ ದೋಸ್ ಕ್ವಾಂಟಿಟೀಸ್ ವಿಚ್ ಆರ್ ಫೌಂಡ್ using these fundamental quantities. This derived quantity depends on the fundamental quantities. Using one or more fundamental quantities, we can find out a derived quantity of an object. For example, density is a derived quantity, and density is found using two quantities here, mass and volume. So mass is a fundamental quantity, volume is a fundamental quantity. So mass by volume, if we do, we get one quantity called density. This is a derived quantity. This is not fundamental quantity. Density is not a fundamental quantity. Mass by volume, see, you can see it's SI unit, kilo per gram. Okay, kilogram per meter. Similarly, velocity, if you want to find out the velocity, again this is a derived quantity. Distance by time, these are again fundamental quantities. Acceleration, area, force, work, energy, all these are derived quantities. ಈ ಡಿರೈವ್ಡ್ ಕ್ವಾಂಟಿಟೀಸ್ಗಳು ಯಾವ ರೀತಿ ಬಂದಿದಾವೆ ಅಂದರೆ, ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟೀಸ್ಗಳನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾವು ಡಿರೈವ್ಡ್ ಕ್ವಾಂಟಿಟಿಯನ್ನು ಕಂಡುಹಿಡಿಯಬಹುದು. ಇಲ್ಲಿ ಒಂದು ಉದಾಹರಣೆ ಅಂದರೆ ಮಾಸ್ ಬೈ ವಾಲ್ಯೂಮ್. ವಾಲ್ಯೂಮ್ ಈಸ್ ಅ ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟಿ, ಮಾಸ್ ಇಸ್ ಅ ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟಿ. ಮಾಸ್ ಬೈ ವಾಲ್ಯೂಮ್ ಮಾಡಿದಾಗ ಒಂದು ಬೇರೆ ಹೊಸ ಕ್ವಾಂಟಿಟಿ ಬರುತ್ತೆ, ಆ ಕ್ವಾಂಟಿಟಿಗೆ ಡೆನ್ಸಿಟಿ ಅಂತ ಕರಿತೀವಿ. ಸಚ್ ಕ್ವಾಂಟಿಟೀಸ್, ಅಂಥ ಕ್ವಾಂಟಿಟೀಸ್ಗಳು, ಸಚ್ ಕ್ವಾಂಟಿಟೀಸ್ ವಿಚ್ ಯೂಸ್ ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟೀಸ್, and after using these fundamental quantities we get a new quantity. Such quantity is called derived quantity. Okay, again we have pressure, stress, and current density. Okay, some of the important practical units, like we have astronomical unit AU, and we have a light year. See, astronomical unit andre ಏನು? Let us understand what is astronomical unit. It is the average distance of the center of the sun from the center of the earth. What is astronomical unit? See, Gpstr ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ ಈ ಕ್ವಶನ್. What is astronomical unit? It is the distance between center of earth to the center of sun. It is the average distance between the center of sun to center of earth. ಅದೆಷ್ಟಿದೆ ಅಂದರೆ, one astronomical unit is 1.496 into 10 to the power 11 meter. That is 1.5 into 10 to the power 11 meter. ಇದನ್ನ ಸ್ವಲ್ಪ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ಆಸ್ಟ್ರೋನಾಮಿಕಲ್ ಯೂನಿಟ್, ಒನ್ ಆಸ್ಟ್ರೋನಾಮಿಕಲ್ ಯೂನಿಟ್ ಇಸ್ 1.5 into 10 to the power 11 meters. ಇಷ್ಟು ದೂರ ಇದೆ ಅಂದರೆ ಸೂರ್ಯನ ಸೆಂಟ್ರು ಮತ್ತು ಭೂಮಿಯ ಸೆಂಟರ್ಗೆ ಇರೋ ಡಿಸ್ಟೆನ್ಸ್ಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ? ಆಸ್ಟ್ರೋನಾಮಿಕಲ್ ಯೂನಿಟ್ ಅಂತ ಕರಿತೀವಿ. ಅದೇ ರೀತಿ ಒಂದು ಲೈಟ್ ಇಯರ್ ಅಂತ. ಲೈಟ್ ಇಯರ್ ಯಾವ ರೀತಿ ಅಂತ ಅಂದರೆ, ಲೈಟ್ ಒಂದು ವರ್ಷದಲ್ಲಿ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನ ಚಲಿಸಿತು ಅಥವಾ in 1 year, what is the distance traveled by light? The distance traveled by light in 1 year is called light year. See, 1 light year is the distance traveled by light in a vacuum in 1 earth year. That means 1 year. ಒಂದು ವರ್ಷದಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟು ಕವರ್ ಮಾಡ್ಕೊಳ್ತು ಲೈಟ್ ಅನ್ನೋದಕ್ಕೆ ನಾವು ಲೈಟ್ ಇಯರ್ ಅಂತ ಕರಿತೀವಿ. ನಮ್ಗೆ ಗೊತ್ತಿರೋ ಹಾಗೆ, as we know, as the speed of light in a vacuum is 3 into 10 to the power 8 meter per second, 3 into 10 to the power 8 meter per second ಅಂತ ನಮ್ಗೆ ಗೊತ್ತಿದೆ. Speed of light, we know that. 1 year is equal to, we know that, how many seconds? To find out seconds in year, 1 year has 365 days. 365 into 24 ಮಾಡಿದಾಗ we get, after doing this we get how many hours In one day we have 24 hours, so 365 into 24 will give us total number of hours in 1 year. Then for 1 minute, 1 hour, we have 60 minutes. So if you do into 60, we will get total number of minutes in 1 year. And again, if you do 60, that means we get total number of seconds in 1 year. So 1 year is equal to 365 into 24 into 60 into 60 seconds. So therefore, 1 light year is, this is a second. In 1 year, these many seconds are there. And for every second, light travels this. Speed of light is this. We know that speed into, we know one formula. What is that? We know one formula. What is the formula that we know? Speed into time will give us a distance, right? So this is the speed and this is the time. In 1 year, how many seconds are there? This is time and this is speed. So speed into time will give us the distance. See here. So speed and this is time. Speed into time is giving us the total distance. That means it travels 9.46 into 10 to the power 15 meters in 1 year. Light travels 9.46 into 10 to the power 15 meters in 1 year. So this is the total distance covered by light. And you have to remember this. The speed of light in vacuum is 3 into 10 to the power 8 meter per second. So ಇದನ್ನು ಕೂಡ ನಾವು ನೆನಪಿಟ್ಕೋಬೇಕಾಗುತ್ತೆ. So hope you understood a very small basic about measurement, fundamental units and derived units, and what is astronomical unit and what is a light year. If you like this video, if you understood this video, if you found this video useful for you, please like, share and subscribe to my channel. And in my next video, I will be sharing about on next topic that is prescribed for you in syllabus. Thank you for watching this video.